Titan Medical Incorporated has developed SPORT, single-port orifice robotic technology. In this video clip, we demonstrate the functionality of the SPORT surgical system as a surgeon completes several tasks that require high levels of precision and dexterity using the system. Tasks include peeling a grape, threading a needle, and passing small beads onto a straight needle. In this clip, the skin of the grape has been scored and the left instrument is used to hold the grape and provide counter traction. The right instrument, which is a curved dissector, is used to grasp the skin of the grape and peel it away from the pulp of the grape. Both the tool and the robotic arm have sufficient precision, strength, and dexterity to efficiently complete this task. The importance of this demonstration is that the tip of the instrument can be predictably moved simultaneously in all three axes so that the surgeon can provide the appropriate force in the right direction at all times during the peeling maneuver. The left instrument, which is a grasper, is used to complete the removal of the segment of skin. The next task involves passing a suture through the eye of a straight needle. With the right instrument, in this case a curved dissector, the surgeon picks up the suture. After picking up the needle with the left instrument, which is a needle holder, the needle can be rotated to easily see the eye and the needle. The surgeon then orients the tip of the suture in an optimal direction to easily pass it through the eye. Using the dexterity inherent in the right arm of SPORT, the surgeon can release the suture and then reach around behind the needle to grasp the end of the suture and pull it through the eye of the needle. To prevent the suture from being pulled all the way through the eye of the needle, the surgeon then ties a knot near one end of the suture. To do this, the surgeon uses the dexterity of the arms not only to move the tips of the instruments to different locations, but also changes the orientation of the arms to more precisely grasp the suture and complete the task. Using all 7 degrees of freedom, the surgeon creates a loop held by the left hand and then passes the right instrument through the loop, grasps the tail of the suture, and pulls the tail through the loop and completes the knot, first by teasing the loop off of the right instrument and then by pulling the suture all the way through the loop. Throughout this demonstration, the surgeon coordinated the movements of the two instruments to work together to complete each part of the task, including pulling the suture back through the eye of the needle, as seen here. The third task in this demonstration is to pass small beads onto a straight needle. By grasping the needle with the left instrument and orienting the needle toward the right instrument, the surgeon can grasp, lift, and position each bead to be dropped onto the needle. By both orienting and positioning the tip of the curved dissector instrument above the bead, the surgeon can grasp the bead by placing one jaw of the instrument into the hole in the bead. Then the bead can be positioned and oriented for passage onto the tip of the needle. This process is repeated for each of the 3 beads, demonstrating the dexterity of the robotic arms and the overall precision of the SPORT surgical system. To complete the task, the surgeon transfers the needle from the left instrument to the right instrument and uses the left instrument to push the beads past the knot of the needle. The tasks seen in this video are relatively simple tasks, but each task has required very complex movements by the instruments. Throughout this video, the dexterity of the SPORT surgical system has enabled the surgeon to complete these tasks reliably and precisely.